Welcome back to my channel. My name is Rakshit Subramanya, a student studying at SVC. Today I'll be talking about the topic single and double-ended priority queues. So let's move on. So before starting, let us know what are queues. Single-ended and double-ended queues. So single and double-ended priority queues are data structures used to store elements with assigned priorities. So if you have seen my previous videos, you'll know that there are other data types such as stacks and linked list. In stacks, I explained it follows the rules of last in first out. So today we'll know about queues which follow the principle of first in first out. So in queues, the first element to come in will be the first element to go out, while in stacks the last element to come in will be the first element to go out. Please do watch my other videos to understand what are stacks and linked lists. Let's move on. Single-ended priority queues allow elements to be inserted at one end and removed from the other end based on priorities. So as I mentioned, the single-ended priority queues follows the first in first out, so the elements enter one end and leave through the other end. So the first element to come in will be the first element to go out. Now double-ended priority queues allow elements to be inserted and removed from both the ends based on their priorities. So as we saw in our previous part in single-ended, how one element entered from one side and left the other side, in double-ended it takes place on both the ends. So let's move on. Structure and operation of single-ended priority queues. Single-ended priority queues are typically implemented using a heap or an array. The main operations supported are insertion, deletion, and sorting and searching, and many more. Unlike stack, in queues you don't call them insertion and deletion. Here I mentioned it so that you can feel easier. But in actual queues, insertion is known as NQ and deletion is known as DQ. Insertion in a single-ended priority queue involves placing the new elements in an appropriate position to maintain the priority order. Here, the priority order refers to the first in first out priority. So the elements must be placed in an appropriate position so that there is no disruption in the priority order. Here you can see in the diagram how it works. Let's move on. The advantages of single-ended priority queues. Single-ended priority queues are efficient for scenarios where elements are mostly inserted and removed from one end. They provide a simple and straightforward implementation compared to the double-ended priority queues. The single-ended priority queues are used in a scenario where elements are processed based on their priority in a sequential manner. Here in the diagram you can see a bit more understanding. For your understanding, as you can see, priority 5, priority 2 and priority 1. To insert the key element K of priority 4, the appropriate node position is before second node. So right now people might be confused. Let me clear you, which I'll be telling it in forward. Double-ended queues use linked list for functioning. So remember, here what you are seeing is an example with the help of linked list. So as you can see, priority 5, priority 2, priority 1, they are all different nodes of a linked list. That is why I said refer to my video of linked lists. So let's move on. So structure and operation of double-ended priority queues. Double-ended priority queues are typically implemented using a doubly linked list or a balanced binary tree. The main operation supported are insertion and deletion of elements from both ends based on their priority. Insertion in a double-ended priority queue involves placing the new element in an appropriate position to maintain the priority order. As you can see in the diagram, as I mentioned, a doubly linked list is used to perform the double-ended priority queues. Let's move on. Advantages of double-ended priority queues. Double-ended priority queues provide more flexibility compared to single-ended priority queues. They allow elements to be inserted and removed from both ends, providing efficient access to both highest and lowest priority elements. Double-ended priority queues are useful in scenarios where elements need to be processed based on their priority in a non-sequential manner. So if you saw in the previous single-ended priority queues, you saw that they need to be executed in the priority based on a sequential manner. While in double-ended priority queues, you see that it needs to be executed based on non-sequential manner in double-ended queues. So let's move on. Use case of single and double-ended priority queues. Single-ended priority queues are commonly used in scheduling algorithms where tasks are processed based on their priority. Double-ended priority queues are used in scenarios such as managing event-driven systems or maintaining a sliding window of data. So, single-ended or double-ended priority queues are mainly used in scenarios managing a event-driven system. By event-driven system, you mean a system which occurs only when there is a confirmation of an event occurring. So let's move on. Time complexity analysis of single-ended priority queues. The time complexity for insertion and deletion in a single-ended priority queue is O log n. You can refer to the graph in the right for a better understanding. So this O log n is based on the graph from the right, where n is the number of elements. The time complexity for finding the highest priority element is O1, as it can be accessed directly from the top of the heap or array. Let's move on. Time complexity analysis of double-ended priority queues. The time complexity for insertion and deletion in a double-ended priority queue is again O log n, where n is the number of elements. The time complexity for finding the highest and lowest priority element is O1, as they can be accessed directly from the ends of the list or tree. Let's move on. Implementation consideration for single and double-ended priority queues. The choice between single and double-ended priority queues depends on specific requirements of application. Consider the expected operation, data access patterns, and space complexity when selecting the appropriate implementation. It is important to ensure that the implementation maintains the priority order correctly to avoid incorrect results. So basically, The single-ended or double-ended priority queues are selected based on the requirements, and when selected we have to make sure that there is no disruption in the priority order so that the result stays accurate. Let's move on. Comparison of single and double-ended priority queues. Single-ended priority queues are simpler to implement and more efficient for sequential processing of elements. Double-ended priority queues provide more flexibility and efficient access to both ends of the queue. The choice between them depends on the specific use case and the operation required. Let's move on. Now let's see the example for single-ended priority queue applications. Job scheduling algorithms in operating systems and implementation in priority-based lists and packet scheduling in network sectors are few of the examples where single-ended priority queues are used. Let's see the next one, which is the example for double-ended priority queues. That is, they are used in event-driven systems where events are processed based on their priority. They are also used in maintaining a sliding window for data for real-time analytics. They are also used in task scheduling in multi-core processors. As you can see what a heap looks like on the right side. Let's see next one. So in summary of single-ended priority queues, we know that single-ended priority queues provide efficient sequential processing of elements based on their priority. They are simpler to implement and suitable for scenarios where elements are mostly accessed from one end. For the summary of the ended priority queues, double-ended priority queues, double-ended priority queues provide efficient access to both the highest and lowest priority elements. They are more flexible but slightly more complex to implement compared to single-ended priority queues. Let's move on. So, in conclusion, single and double-ended priority queues are essential data structures for managing elements based on their priority. The choice between them depends on the specific requirements and access patterns of the application. Understanding their structures, operations, and advantages helps in selecting the appropriate implementation. Thus, I hope you understood something from my video. Thank you. Please do like and subscribe.